Hello and welcome to this video about Pandas for data handling. We're excited to have you here, and in this video we're going to talk about data preparation with Pandas, and specifically we will talk about how to technically handle missing values in a Pandas data frame. Missing values comes in many types, and missing values, also called missing data, may affect analysis and algorithms negatively. It is therefore necessary to check for missing values or missing data and to handle discovered missing values or missing data. In this video, you will learn about how to find missing values or data in a Pandas data frame, and you will learn some ways to handle these missing values or missing data. And these methods include imputation and advanced model-based imputation. Now we'll talk about what missing values are, and you will learn some common ways of handling missing values. Missing values are unfortunately common nowadays in both large and small datasets, and the missing value is defined as that a row or rows in a column lacks recorded data values, or that entire rows have no values at all, or that the column name is missing from a column. Sometimes these missing data values may be completely missing, and this means that you have an empty row or an abstract missing row, which you know about from other data sources. For example, that individual X is missing because it occurs in dataset A but not in dataset B, which both should contain this data. Sometimes you will have a key but no values or data, and sometimes you will have a key and some data but not all data. And sometimes you will have the full or partial data but no key. And these are the main types of missing values, and just as with duplicates, the missing values may skew the analysis and create errors or biases, but usually in the other directions of error than the duplicates. And now we're going to talk about Pandas definitions of discovered and marked missing values. And Python and NumPy, which Pandas is built on, and Pandas use different abbreviations for missing values. Python used the NON abbreviation, NumPy the NP.nan abbreviation, and Pandas none. NA is also frequently used by Python or Pandas data code and means not available. And there is also many other ways to describe or encode missing values, and many computer programs and databases have their own ways of labeling missing values. An old numerical tradition is to use a star to denote a missing value. And in this tradition, the star corresponds to a could be anything interpretation. Many databases have their own unique string codes or other codes representing missing values. Missing values requires knowledge about the datasets, the data collection, and involved programs and databases. And we call this subject matter knowledge. And you have to handle all of these things and acquire the subject matter knowledge for every situation. So now you will learn how to treat missing values, either by dropping rows with missing values or by filling in replacements for the missing values. We can of course also exclude entire columns or rows with missing values if we want to. And now we're going to talk about and show you how to use Pandas drop NA and fill NA functions to handle missing values. The drop NA function drops rows with missing values, and the fill NA function will fill in values to use instead of a missing value, as specified by the fill NA function's argument. And data scientists and machine learners often face a dilemma when considering whether to drop or fill in or impute missing values. How you shall treat missing values is within the realm of the subject matter expertise, and this issue is clearly dependent on the analysis you want to do, whatever data you have, and whatever application you are building. And clearly, physical measurement data from digital systems are different from social science data, geographic data, web data, real-time data, historic data, estimated data, predicted future data. And there are so many applications and so much data that you have to study each case individually from general guidelines. And when we remove missing values, it is often considered acceptable to remove damaged or partly missing values from the equations. And the much more controversial subject is the use of functions to replace missing or strange data or to execute so-called qualitative imputation of values, to define missing values through a mathematical equation or a subjective analysis and determination of what values the missing values should have, or what is a reasonable data value to replace the missing values with. And the controversial part of the debate is a consequence of that you modify the data and don't let the data speak for itself in the analysis. And this means that you subjectively change the data, as you say, to make a better estimate or result for your analysis. Another data scientist may doubt the result and effects, and therefore imputation and subjective interpretation are controversial or speculative in nature within the scientific community, whereas within the private sector, in the business sector, imputation is acceptable as long as a better result are achieved within the business. So right, now we're going to type some code, so start up your code editors. Alright, having started our Jupyter Labs notebooks, we will now type some code and you will learn how to treat missing values. And we will show you a whole set of options to handle the missing values, and we will also have a little discussion on how to handle the missing values and the requirement to use subject matter knowledge to handle missing values. So here we can see that we already have some code typed to our Jupyter Labs notebook, and we will import pandas as PED, and we'll import the library matplotlib.pyplot as plot. And we will use matplotlib to visualize some imputations. We will import a JSON dataset from Seaborn, which we will use to show regression imputation. And we'll import Seaborn as SNS in order to get this dataset. And we will import the linear model from scikit-learn, because we will use scikit-learn's linear model for regression imputation. And we will also use our car sales data frame. And in this case, we will modify the standard car sales data frame with missing values, so we can test our missing values code on it. So as you can see in this data frame, we have several non-values inputted in our car data. And when we create a Pandas data frame from this car data dictionary, we will get a Pandas data frame with missing values. So let's run this code. And here we can see that we have 3 missing values in this data frame. So we can see the value not a number. And the first thing we will do is that we will create some descriptive statistics for missing values. So we type descriptive statistics. or missing values. And we can create a car sales missing value. Is null data frame, and we can set it to car sales. Is null. And we can print our car sales missing value is null data frame. And this data frame will contain a Boolean matrix of true or false to the question is null. So if you have is a null value or a not a number entry in a data frame, it will return true for that entry. So let's run this code. And here we have a is-null matrix, where, for example, the not a number entries have true, and the entries with proper values have false. And now we will print statistics over missing values per column. And we can print car sales missing value is null. And we create a sum of this. And we make a little change there. So let's run this code. And here we can see a table with statistics over missing values per column. So here we can see the Mercedes column, we have one missing value. We have the Renault column, we have two missing values. And we have the Ford and Tata column with no missing values. And as you can see, this is quite useful. And we can make more descriptive statistics without missing values. And note that for some standard function, missing values are dropped on a per column basis by default. We can type print car sales mv dot describe. Let's run this code. Here we can see that 5 count values are included in the Mercedes column, and that 6 are included for the Ford and Tata columns and 4 for the Renault columns. And this corresponds to the missing values. So here we can see that the standard described statistics function drops missing values per column by default. And this is very useful to keep track of. And now we will show the drop missing values by rows or columns function. We type drop missing values either by rows or columns. And this means that we drop entire rows or columns if a missing value exists. We type car sales 2 equals car sales missing value drop NA. And we can create a car sales 3 missing values. And in this case, we set the axis to 1. And we print car sales 2. And we print car sales 3. So let's run this code. And here we can see that with the first drop NA instruction, we dropped all rows with a missing value. Here we can see that because Renault has 2 missing values, those 2 rows were dropped. And as we can see, the missing value for the Mercedes was in the same row as the Renault. So if, for example, we had had a missing value in row 2 for the Mercedes, then we would have 3 rows in this table. And in the car sales 3 data frame, we now have 2 columns because we had axis equals 1. And this means that all columns with missing values were dropped. So this is 2 ways of handling missing values, which are considered useful when you have a large data set with very few missing values, but which can be very destructive to data in a normal data frame where you have a lot of missing values, perhaps randomly distributed over the data frame. And a lot of other methods are motivated with keeping more data and thus creating more information from the data. And now we will showcase basic imputation. And the first basic imputation is to enter zeros to replace the missing values. So now we'll type car sales, zero fill, equals car sales, missing value, fill NA, zeros, and in place equals false. And we will print car sales, zero fill. So let's run this code. And the in place equals false makes sure that our original car sales missing values data frame is not affected by this operation. And here we can see in our resulting data frame that the missing values has been replaced by zeros. And now we will look at a more advanced type of imputation, which is to replace the missing values with the means of the existing values. So we type imputation, means, replace the missing values. And we type car sales, mean, equals car sales, missing values, dot mean. And here we can type that pandas mean don't include null values in its calculation. And this is important to consider because many other functions may interpret a missing value as an existing function for the count issue when you calculate the divisor for the mean. And this is even more true if you have a database with a particular code, for example, the star or a string code or a number code for a missing value. And we will type car sales, mean fill, car sales, missing value, fill NA, car sales mean, and in place equals false. Print car sales mfill. So let's run this code. And here we can see that the missing value has been replaced with the mean for the column. And now we'll talk some about subject matter expertise in terms of the car sales dataset, which we have used now. And we will begin by imagining that you work as a data scientist in a company headquarters and that you get these reports from different sites or sales places around the world. And you have missing values in your dataset. So naturally, you call the sales places and try to get these missing values, but you know they can't deliver them for some untold reason. So what do you tell the boss, or which statistics do you make? Do you impute zeros for the missing values, or do you impute the average of the known sales, or perhaps the average of the last quarter's sale, or the same quarter a year earlier, with the possibility of creating fictitious sales which never occurred? Or do you tell the management that you don't know what the sales are, so you must assume that they are zero, which could be very useful and put some pressure on them, and put some pressure on you in return? Or perhaps will you impute the expected performance based on your boss or the big boss's stated goals for the sales, or something similar? And as you understand, all of this requires subject matter knowledge about everything from the company to the hierarchy of the company, to the sales places, the persons, the data, the nature of the events, the circumstances, and all such things. And in every specific case, detailed subject matter knowledge about the circumstances for what is needed to make an effective good and reasonable imputation of missing values is needed. So when you are doing imputations, you must consider all of these things. And I think that this example explained some of the more debatable issues with imputation and its general subjectiveness. So now we are going to show you some advanced imputation techniques using Seaborn's geyser dataset, which describes geyser eruptions. And geyser eruptions are a function of nature. It is pressure, it is heat, it is all of such things that build up and creates a geyser. And it is the laws of nature that creates this geyser eruption. So there is no social subjectivity or social pressure inside a geyser's eruption. And the first thing we will do is that we will load the dataset into a Pandas data frame from Seaborn. And we never did that up here, so we have to type this code. And we begin by typing imputation, regression, imputation. Let us load the geyser dataset from Seaborn and make a copy of it. We type geyser equals Seaborn, load dataset, geyser. And we print the geyser dataset, and we create a copy of it. And we make a deep true copy. So let's run this code. And here we can see that the geyser dataset has 272 rows and 3 columns. And we will look at the duration and the waiting time variables. And duration is the duration of the geyser's eruption, and the waiting time is how long it takes before the eruption starts. And what we will do now is that we will design some missing values in the geyser data. And to do this, we will create a number list 1, and we will fill it with some values. And we create an endlist 2, which we will also fill with numbers. Like this. And we type for n in nlist 1, geyser 2, locate, and for n in nlist 2, and here we can just copy, and we can print the result and make another data frame copy. We type print geyser 2, and we print geyser 2 is null dot sum, and we type geyser 3 equals geyser 2 dot copy, and d equals true. So let's run this code. And here we can see that we now have missing values in the geyser dataset. And we have the statistics for the missing values. So we have 9 missing values for the duration and 5 for the waiting time. And this corresponds to our list. Here we can see, for example, we have the list number 4, and we used it to point to the index position 4 for the duration variable, and we made it a none value, a missing value. And now we'll begin with the model-based imputations. So we type simple model-based imputation. Pandas linear interpolation function is used to impute values according to some simple interpolation model algorithm. And we will try the linear method. We type geyser 2 duration interpolate method equals linear in place equals true. And we copy this. And we make a little change. And we will plot the result using matplotlib. We type geyser2 plot gather x equals duration, y equals weighting, color equals blue, marker equals x, x equals x. And we plot the original geyser data frame without missing values. And we make it red and give it pluses as markers. So let's run this code. And here we can see that red are the originals. And where there are no missing values, the pluses and the x's will overlap each other. So you can see that where we have no changes, they overlap each other. And where there are missing values, they are singular red crosses. And the corresponding imputed value is blue without any red inside it, and an X. And this is a bit cluttered, but as we can see, this linear formula with its secret algorithm, which is not very well described in the manual, is not performing very well in this graph and in this data material. And this is likely due to its localized nature. And we can type, as we can see from this plot, point, click, and forget imputation with models may cause arbitrary results, and careful study of the data is needed for useful imputation. And this is important to remember, that in many cases these standardized half-secret methods may cause arbitrary results, and in some data materials they may cause good results. But you don't really know which of the cases it is you have for a particular formula unless you make this deep study of the data. And now we will show some ordinary model-based imputation where we have control and know exactly what our algorithm executes. And in this case, we will use a dual simple linear regression model to estimate the missing values on a new copy of the geyser data frame with missing value rows dropped. And we will create a scikit-learn linear model on a data frame without missing values. And we can say that the data frame has dropped the missing values. So we type geyser4 dropped missing values equals geyser3 drop NA, and we type model1 equals linear model linear regression. We create two regression models, and we take model 1 and we fit it to x equals geyser4 dropped missing values duration y equals geyser4 dropped missing values weighting. And we copy it. And we change it to the other model. And we run this code. And here we have created two models without any explicit output. So the first thing we do is that we create a data frame geyser4 with dropped missing values. We initialize two scikit-learn linear regression models, and we train them on the geyser4 data frame with only two variables, one target variable and one input variable. And now we'll type that some limitations in scikit-learn's linear model creates a need for modifying the null values or for making sub-selections of is not null values. And here we modify the null values by setting them to extreme values. We type geyser free, waiting, fill NA, and we can choose the value 10,000 as an extreme value. In place equals true, and we copy this. And execute the same operation on the duration variable. And we create an estimated duration variable by using model 2 predict geyser free, waiting. So here we send in the variable waiting from the geyser free variable as input variable to model 2, and we use it to estimate the duration given the waiting times. And we will copy this instruction and create an estimated waiting time. Like this. And for this operation to work with the linear model, it is absolutely necessary to replace the missing values with extreme values, or to make a subselection of is not null values. And in this case, we use the extreme value approach because it is slightly simpler. And after creating the estimations, we will replace the extreme values with estimated values, which is the imputations. So let's type geyser free, locate, geyser free, duration, larger than 5,000, duration equals geyser free, estimated duration. And we copy this instruction and we change it to waiting. and we print geyser free. And we make a little change here. So let's run this code. And here we can see, for example, one extreme value. And we can see that those has been replaced by estimated values. And it seems to be ready to go, so let's plot the results. We type fig. Like this. So we cut and paste this code. Let's run this code. And here we can see our new imputations in blue. And we can see that they are all centered and that they are much closer to the original values than in the earlier model. And while we didn't use any randomness to this linear model, which it usually has a random component which we could have estimated to create some more uncertainty to this data, we can see that they fit this data very well. And as you can see, all of these imputed values, they all lie on a regression line through the dataset. And similarly as before, we can conclude that the subject matter knowledge is necessary and that the models both can increase and decrease the variability of imputed data points. So while the earlier model created too much variability in the data, this new model likely is a bit too tightly centered along the regression lines from these two models. But the useful thing with this type of handling imputation is that we can take control of this model-based approach. And with this workflow and work model, which we have shown in this video lecture, you can input any type of model from scikit-learn or any other similar Python library for modeling. And you can make imputations according to such a model. But as you understand, this is very useful. So, to conclude, in this video you have learned some very valuable and important stuff about missing values, how to treat missing values, and you have learned some advanced model-based imputation of values. And in the next video we will talk about useful data description and descriptive statistics. And we look forward to see you in the next video.